Alright guys, this next lesson is called 2-7, 3 variable systems. Please set up your notes and then press play when you're ready to begin. Alright, so we're going to write down some steps, and there are quite a few. So I'm just going to show one step at a time, and I want you to pause the video to make sure you're getting this all written down. In order to solve a 3 variable system, you have to do a ton of elimination. It's like a big puzzle and we're solving for each piece. The first step is to choose 2 of your equations in which you can easily eliminate a variable. This is called equation A. So after you eliminate a variable, you're going to be left with a new equation. You're going to label it A. The next step is to eliminate the same variable from a combination of one equation you've already used and the third equation that has been unused. This new equation is called B. So once these 2 steps are done, you're going to have an equation A and equation B. Third, you're going to put equation A and B together like you're creating a new system of equations and solve that system. Once you're done solving that, you're going to have 2 of your 3 variables. Once you have 2 of your 3 variables, you can move on to step 4, which is to substitute your answers from step 3 into one of the original equations. You get to pick any of the 3. That is going to help you find your third variable. And when we write our solution, we write it as x, y, z. Again, make sure you're pausing the video to write all of this down. Once you have all the steps written down, go ahead and play the video, and we're going to get started with some examples. Example number 1. Let's say I have a 3 variable system with these equations. 2x minus 6y plus 9z equals negative 8. My second equation is 5x plus y plus 2z equals 10. And then my third equation is 3x plus y minus 8z equals negative 28. Okay, so step 1 is to find 2 equations in which we can easily eliminate a variable. I'm going to be using the same color as my steps, okay? And so step 1, the equations that I think are going to be the easiest to eliminate a variable is going to be the y's. I think that these y's are going to be the easiest to eliminate, so I'm going to choose those for step 1, and this is going to make my equation A. So I'm going to go ahead and write this down. A is going to be 5x plus y plus 2z equals 10, and then 3x plus y minus 8z equals negative 28. I'm going to go ahead and just solve this system. So when I do that and I take a look, my y's, in order to eliminate these, I'm going to want to subtract, because y minus y will be 0. So I'm going to subtract those to eliminate them. And so 5x minus 3x is 2x. 2z minus 2z minus negative 8z would be like adding, so that's going to be a 10z. Be careful with those signs. And then 10 minus negative 28 is going to be 38. This is equation A. I'm just going to hang on to that for a minute. Now I've got to go to step 2. I use teal for step 2. So it says, eliminate the same variable from a combination of one equation you already used and the third unused equation. So I have not used this first equation. I need to eliminate y again. And so I'm going to pick this third equation that we haven't used yet, and then one of these 2 that we already used. It doesn't matter which one you pick. I'm just going to pick the first one and the second one, only because I see that there's a 10 here and there's a 28 here. This one has a smaller number. Again, it doesn't matter. I'm going to use these to create equation B. So down here, equation B is going to be 2x minus 6y plus 9z equals negative 8. And then 5x plus y plus 2z equals 10. Now if we remember in the elimination method, in order to eliminate my y's, they have to have the same coefficient. So I have a 6 in front of this y, but this y doesn't have a 6. So I need to multiply this entire equation in order to get a 6 in front of my y. I'm going to multiply the whole thing times 6. I want to rewrite my equation the same way, so I'm going to list this first equation will go on top, 2x minus 6y plus 9z equals negative 8. And then my second equation, with everything multiplied by 6, I will have 30x plus 6y plus 12z equals 60. Everything has to be multiplied by 6. Now, for this negative 6y and this positive 6y to be 0, should I add or should I subtract? I'm actually going to add, because negative 6 plus a positive 6 is going to be 0. So that eliminates my y's, and then I'm going to add the rest of my terms. 2x plus 30x is 32x. 9z plus 12z is 21z. And then negative 8 plus 60 is going to be 52. And this is equation B. Now if we take a look in equation A and in equation B, we have two equations with the same variables. So now I'm going to put these equations together like it says to do in step 3 and solve this system. At the end of this step, I'm going to have something for x and I'm going to have something for y. So A and B. So my A equation is 2x plus 10z equals 38. And my B equation is 32x plus 21z equals 52. Now I can't just go eliminating unless my variable terms have the same coefficients. So I'm looking at the x's because it's going to be the easiest to make this 2x a 32x. So what can I multiply 2 by to get 32? I'm going to multiply it by 16. So that means the whole equation gets times by 16. And so I'm going to rewrite this system now. 2 times 16 is 32x. 10 times 16 is 160z. And then 38 times 16, I'm going to need a calculator for that one. Okay, so let's see. 38 times 16, 608. And then my second equation in my system stays the same. 32x plus 21z equals 52. Now looking at 32x and 32x, should I add or subtract to eliminate? And I'm going to go ahead and subtract these equations. And that's going to eliminate the 32x's. Now I'm going to subtract 160 minus 21, and I get 139z equals 608 minus 52, which is 556. And then to solve for z, I'm going to divide by the coefficient, which is 139. This is why it's so important to have these skills of solving equations. We're going to use them forever in Algebra 2. And then 556 divided by 139, I get 4. Z equals 4. Now I'm still in this system. I'm still trying to solve in this system. So I'm going to take this and I'm going to plug it into one of these equations and solve for x. I'm going to choose this first equation because my numbers are smaller. And so I'm going to plug in a 4 for z and solve for x. So 2x plus 10 times 4 equals 38. 10 times 4 is 40. And so then if I subtract 40, I'm going to get 2x equals negative 2, and so x equals negative 1. So we just plug it in like we're used to, and we solve for x, and we get x equals negative 1. Now, our very last step says that we can substitute our answers here, z equals 4 and x equals negative 1, into any of these three equations to get our solution for our third variable, which is y. I'm going to pick the third equation because I see this one has a y by itself, no coefficient, and it looks like my x is smaller, my 8's a little bit bigger, but it doesn't matter. Again, you can pick any of these. So, keeping with my colors, my fourth step is in this bright pink. I'm picking this equation here, and I'm going to plug in x and z. So 3 times -1, which is my solution for x, plus y, we don't know what y is yet, minus 8, and my solution for z was 4, equals -28. Alright, so let's simplify this multiplication. We get -3 plus y minus 32 equals -28. Combine like terms, so y, and then we've got a -3 and a -32, which is a -35, equals -28. Add 35 to both sides, and we get y equals 7. We do want to check our answers, but it's okay to use a calculator for this part. So I'm going to scoot this up a little bit, and I'm going to show my calculator. I'm going to check. Alright, so I'm just going to plug x, y, and z into each equation and make sure I get a true equation. So the first one, 2 times, and then my x is -1, minus 6 times my y, which is 7, oops, plus 9 times z, which is 4, and I should get -8. And I get -8. Checking my second equation, 5 times x, which is -1, plus y, which is 7, plus 2z, which is 4, and I should get 10. So far, so good. It has to work for all 3 equations, though, so I do need to check the third one, even if the first 2 work. So 3 times my x, which is -1, plus my y, which is 7, minus 8 times my z, which is 4. And I get -28. Once I've checked my solutions, then I can write this as x, y, z. So my solution is -1, 7, 4. Alright, we're going to do one more example of this together. So our second problem is going to be 4x plus y minus 3z equals 45. Equation 2 is 6x minus 4y plus 3z equals 41. And then our third equation is 2x minus 7y minus 11z equals 85. So step 1 is to choose 2 equations in which we can easily eliminate a variable. And so in my opinion, the first 2 equations, I can easily eliminate the z's. These will be equation A. Okay, so A, 4x plus y minus 3z equals 45, and then 6x minus 4y plus 3z equals 41. Taking a look at my z terms, they have the same coefficient in front. Should I add them or subtract them to eliminate? I'm going to add them. Signs are opposite, so we're going to add them. And now that means I'm going to add all my other terms vertically. So 4x plus 6x is 10x. Y plus -4y is -3y equals 45 plus 41 is 86. So this is my new equation A. Now we're going to choose 2 other equations for equation B. One that I've already used, and then this third one. It doesn't really matter which way you decide to do this. I'm just going to go ahead and pick these 2, and I still have to eliminate z. So keep that in mind, that these first 2 steps you have to eliminate the same variable. So for equation B, it'll look like this. I've got 6x minus 4y plus 3z equals 41, and 2x minus 7y minus 11z equals 85. So if I'm trying to eliminate z, then these have to have the same number. And so what number could I make those both so that they can eliminate? If it's ever difficult for you to decide, you could just multiply these numbers together to figure out what that least common multiple is. And so 3 times 11 is 33. So I'm going to make both of these a 33. So that means I have to multiply equation 1 times 11, so that this is a 33. And then I have to multiply equation 2 times 3, so that this is a 33. And that's going to create 2 new equations for me that I can use to eliminate and make equation B. So 66x minus 44y, everything gets times by 11, plus 33z equals, and then 41 times 11, 451. And then my second equation times 3. So 6x minus 21y minus 33z equals, and then 85 times 3 is 255. Now looking at my z terms, should I add them or subtract them to make 0? Since my signs are opposite, I'm going to add to make 0. And that eliminates my z's, leaving me with x and y left over, which is good because, again, we have to have the same variables left over. We have to eliminate the same variables as we did in equation A. So 66x plus 6x is 72x. Negative 44y plus negative 21y, well, that's like subtracting them. So we get negative 65y equals 451 plus 225, and we're going to get 706. This is equation B. After we have found equation A and equation B, we're going to put them together to create a new system where we can solve for both variables. So A and B together, we've got 10x minus 3y equals 86, and then 72x minus 65y equals 706. So if we're going to use the elimination method again, we've got to make either the x's the same or the y's the same. So I think it's going to be just simpler to do the x's. We can make these both 720. Let's just multiply this whole thing by 72 and this whole thing by 10. You can think of a least common multiple other than that, that's fine. But sometimes we just want to multiply one by the other. Okay, so if I do this first equation by 72, I'm going to get 720x minus 3 times 72, which is 216, y equals 86 times 72, and it's okay if we start getting big numbers, 6,192. As long as we're following the same steps, we're going to be just fine. And then each of these by 10 means I'm just going to add a 0 to everything. So 720x minus 650y equals 7,060. Now looking at my terms here, 720 and 720, should I add them or should I subtract them to make 0? I'm going to subtract them because they're both positive. And so now we've got negative 216 minus negative 650. Again, pay close attention, this is minus a negative. And we get 434y equals 6,192 minus 7,060, and we get negative 868. Divide by 434. Divide by 434, and we get negative 2. Y equals negative 2. We're still in the same step because now we're going to use this solution for y and plug it into one of our original equations in this AB system. I'm going to pick the first one because these numbers are smaller. So 10x minus 3 times negative 2 equals 86. 10x plus 6 equals 86, and then eliminate the constant to isolate the variable. So we get 10x equals 80, and then divide both sides by 10. X equals 8. Now, the last step is to substitute both of these, x and y, into one of our original equations to solve for z. Again, it does not matter which one you pick. I'm going to go ahead this time and I'm just going to pick the first one. So this is the equation that I'm going to use. I'm going to put a star next to it just so I know for the sake of my work. 4 times x, which we got was 8, plus y, which is negative 2, minus 3z equals 45. So we're going to simplify this. We've got 32, and then positive negative is a negative, negative 2, minus 3z equals 45. 32 minus 2 is 30, minus 3z equals 45. We're going to subtract 30 to eliminate this constant. And so we bring down that negative 3z equals 45 minus 30 is 15. Divide by negative 3, and we get our solution. Z equals negative 5. Now, to check our work, we're just going to plug all of these into our original system really quickly before we write our final solution. So, using my calculator here, I'm just going to plug them in real quick. The first one, 4 times x, which is 8, plus y, which is negative 2, minus 3z, which is negative 5, and I should get 45. Yay! Equation 2, 6 times 8 minus 4 times y, which is negative 2, plus 3 times z, which is negative 5, and I should get a 41. And the last one, 2 times 8 minus 7 times negative 2, minus 11 times negative 5, and I get 85. So all that work was not for nothing. We got the solution. So we'll write that as a set x, y, z, 8, negative 2, negative 5.